A first use case of SitCom is to simulate perceptual components. These perceptual components will typically provide us with events of all sorts, which are described in simulation files. Through a perceptual component simulator, the simulation files can be read and the events presented through the CHIL Perceptual Component API. Consumers of these events are typically the situation model and the SitCom graphical user interface, which can display these events and can also display the resulting situations. In this way, we can actually check if a perceptual component produces the proper situations. To simulate perceptual components, we can load some event files. These event files provide information like Jeff is entering the room, the door is opening, and so on. So now we load a set of 5 of these files. Here we have some simulation buttons in which we can actually run these events. To verify that it has some effect, we will load some services, one of them being the occupancy service, which will indicate us how many people are in the room and their identity. So here you see that we have one situation running. Here we can play with the playback speed of the simulation. So let's start the simulation at 10 times real-time speed. So here we can see that we have people entered the room, we have the label of the people here, and we have one person talking. At the same time, the attendance situation is telling us that it has detected 3 persons, and 2 of them have a name, and 1 has not been identified yet. This is to simulate a perceptual component which may provide the identity of a person based on audio, and the person hasn't been talking yet. Now a 4th person enters, and at the same time, the 3rd person has been identified. So you can see that we can simulate a set of events from the perceptual component, feed them into the SitCom GUI, and at the same time feed them to the situation model and have some display of what is going on in the situation model. Another use case of SitCom is to test services and situations. With the same simulation files as we have talked before, we can feed them through the same perceptual component simulator, and they're fed to the situation model. Several situations can be loaded at the same time to support different services like the connector service for Jeff or the occupancy service of the room. All these information can then be displayed in some summarized way in the SitCom graphical user interface. In case we have perceptual components which can provide additional information as a video stream or multiple, we can actually load a special service we have written to display this additional information. This service will give us an additional view in the SitCom graphical user interface. So here we have the room video. Now we will load a set of pre-recorded events from the different perceptual components. So these are events which are actually processings of real perceptual components. Because this is involving video, we will play it back at a regular speed. So now if we play back this set of events, we will be able to see here what the analysis of the situation is as known to the situation model, for example, and as known to the different cameras. So these are the 4 cameras which were in the room, and we can observe the different video streams which have been recorded. So this is the camera number 1, and I'll show you the different other cameras. These perceptual components had an additional information which is a flag if the speaker is facing the camera or not. From this information we can infer an approximation of the heading. We have written a small situation which we can load now, which I loaded, and which updates the heading of the particular person in the model as known to the situation model. As you can see, SitCom is actually now displaying this approximate heading of the speaker. So we have seen here that we can actually test different situations and at the same time relate them to what the perceptual component gave us. A third use case of SitCom is to verify that the situations can deal with live feed. In the case of a camera, we may have face detector perceptual component, which presents its face events through the perceptual component API. This can be fed in the situation model, and the result can be displayed in the SitCom graphical user interface. In this way, we can test if a perceptual component is suited for a particular situation. So we have a perceptual component which takes a live feed of a camera and extracts face events as soon as it detects a face. So this implements the Perceptual Component API. So all the face events are actually relayed through this API to the situation model, which will update its internal state and create a new entity of type person. At the same time, the situation GUI, as you can see, has updated this current state of the situation model. If now Honza is joining me, so we will have two faces detected, and the system will actually update the situation model internals and also the GUI. Now, if we move out of the picture, of course, the entities will disappear.